Good morning, good morning, good morning. How are you all, guys? Is my audio, video, everything all right? Can we move forward? Today, we'll be discussing the last topic of electronics. शुरू करा जाए दोस्तों. Can we start list square footing? And if you have any question from the previous class, Harry, you asked some question. Huh? Let me check. What was your question? In this type of problem, we should square them and then we to take square root for these terms. I got slight difference in my answer. I consider root first and okay. So what you have asked, you should start with a square. A sigma square, then let's say u, if you have a quantity, derived quantity, let's say u is a function of x and y. You should first calculate sigma u square. Okay, then if it requires, then at the end you can take a square root. Okay, so taking square at the first place is necessary. Okay, so let's start today's session. Least square fitting is one of the most important topics. You can expect a question of 5 marks in the part C from this topic if any question comes. So there are few types of least square fitting, fitting line or fitting some nonlinear curve. So what happens whenever we do experiments, we get some experimental results. Now we try to decide like what kind of curve fits our experimental data, whether a straight line is fitting our experimental data or an exponential is fitting our exponential data, or Gaussian is fitting, or Lorentz, so there is something called Lorentz curve, okay, or any polynomial is fitting. So we need to decide that our experimental result is following this particular mathematical. So once you are able to fit it, you are able to fit it into a mathematical formula. That is why this is important. Curve fitting is the process of establishing a mathematical relationship. This is the ultimate thing. We need a mathematical relationship for the validation of our data point. The data points are following certain mathematical relationship or best fit curve to a given set of data points. This relationship may be used for number one, testing existing mathematical models, establishing new ones, and predicting unknown values. Okay, so let's say you have got some data point in this form. This is randomly scattered. Now you know all these data points, this. So from this pattern, you can fit it to some curve. Let's say we are fitting it to a straight line like this. Now up to this, you already know the value. Now with the help of this curve, with the help of this fitting curve, you can predict that the value at this point will be this, value at this point will be this, approximately near about this. So this is used to predict unknown values. That is why least square fitting is an important thing. Least square method, LSM, is a mathematical procedure for finding the curve of best fit to a given set of data points, or that the sum of the square of residuals is minimum. This is the ultimate thing. You have to find out a curve, find out the best fit, so that the sum of the squares of residuals is minimum. What is residual? Residual is the difference between the observed and the estimated values of dependent variable. So you need to make the sum of the squares of this value minimum. So understood what is all about the least square method. Observed and estimated. You can see method of least squares can be used for establishing linear as well as non-linear relationship. So linear relationships you can see in this figure, like you have got a lot of data points. These data points. So you see, now you have imagined an arbitrary curve. Let's say y is equals to a plus bx. Now evaluating the residuals, okay? Evaluating the residuals, taking the squares and minimizing that. After doing that, you will get to know there are two unknown values of AB here, unknown values, right? Unknown values. Depending on AB, your curve will be changed. Your curve may be, if A equals to 0, your curve will start at the origin, will go like this. If A is some positive value, your curve will go like this, or it may go like this. It may go like this. If B is negative, it may go like that. So you do not know what straight line will perfectly fit for your data point. You got your data points in this way. You may get your data points scattered in this way. So you do not know the perfect slope of the curve. If you can decide these two values A and B, you will be able to uniquely define a straight line which will fit your data points. The same is true for nonlinear plots. You may not get the data points in such a fashion. You may get in the form of a nonlinear curve. In that case, you have to fit it to some polynomial, just say a plus bx plus cx square in this way. Or it may be it may require some more higher powers of x to fit the data points. Data points may not come in a very systematic way. Sometimes they can come randomly. In those cases, you have to use polynomials. You got the basic understanding of least square fitting. Now let us start with one by one. The most prominent or most important one is the linear fitting. Least square method for fitting a linear relationship. This is also called linear regression. So as I told you, linear fitting, so the basic linear equation of this form, y is equals to a plus, this is the standard linear equation. So with the help of this, it has a meaning of fitting a straight line. So whatever data point we have got, it seems that they can be fitted with a straight line. Now we need to get the value of a and b. Now let's say I have n set of values. Consider a set of n data points. Let's say data points. How will you give? Let's say for x1 we have the value y1. This is one point. For x2 we have the value y2. This is another point. For x3 we have the value y3 and so on up to, let's say, for xn we have the value y. Good morning, Vantage, Murli, Hari. Your messages are coming so late. Were you able to hear me before, or it just came so late? The main thing is, suppose Acha, Harry, you were late today. Actually, I answered your question you asked on WhatsApp, right? Well, let me answer it again. You asked, no, we should square them and then to take square root of those terms. So you have to take square first. Let's say you have a quantity u, which is a function of x and y. You need to calculate first sigma u square. Then you will write the formula. Then you will put the necessary values. And at the end, if you require to take square root, you will take the square root. Okay. So suppose we have find linear relationship in the form y is equals to a plus bx to fit the above set of values. Now what you have to find out? You have to find out the difference between the observed and estimated value. Okay. So the difference between the observed and estimated values the difference between the observed and estimated value of y is called the residual. And is given by, look, for the first one we are writing this much, but for the upcoming one we will not write, we will just directly write the residual. Residual is equals to how much? Difference between the observed and estimate. What is the observed value? These are the observed value which you have got from the experiment x1, y1, x2, y2. So we can write in general yi. What is the estimated? Which means we are predicting. We are predicting this value from this curve y equals to a plus bx. Okay. So we are predicting that the value of yi at xi is equals to a plus bxi. Can I write it? This is the estimated value. This is the observed value. Clear? So in the least square method, in short, it is also written as LSM, least square method. We have to find constants. We have to find a and b. Such that sum of the residual square, you see, look at the language. Sum of the square of residuals is minimum. Sum of residual square is minimum. We have to take the sum. So let's say let T, we are denoting T is the residual square. Okay, because when we will be writing del T by del A or del T by del B, to make it simplified, we are using this symbol of T. T is equals to sum over Ri square. So this is sum over I, yi minus a plus bxi square. This should be minimum. Now under what condition this quantity may be minimum? If the first derivative is 0. Okay. the condition for t to be minimum, what you require? Del t divided by del a. Del t by del a equals to 0 and del t by del b equals to 0. These two conditions need to be satisfied for this quantity t to be minimum. So we just need to find out this. So del t by del a equals to 0. What does it give you? Look, del t by del a equals to 0. You take the derivative with respect to a. So what you get? 2 times sum over I yi minus a plus bxi, derivative with respect to a, so into minus 1. This is equals to 0. So this is, you can say, look, minus 2 is observed with 0. So what you are left with? Sum over I yi minus sum over I a minus plus minus b is constant, sum over I xi, this is equals to 0. Can I write it? This is one relationship we got. Now take the other one. Del t by del b equals to 0. Del t by del b equals to 0. If you take this, what you get? Again 2 times sum over I yi minus a plus bxi. Now we are taking derivative with respect to b, so minus b xi, so it will come minus xi, right? Derivative with respect to b, not xi, okay? So b is the variable now, xi you can take constant, so minus xi will come, and this is equals to 0. Now this minus 2 can be absorbed, or you can also keep minus. So this is minus sum over I xi yi, okay, minus minus plus a times xi minus minus plus b times xi square, this is equals to 0. Now this can be also simplified, okay, if you have already done it. This can also be a little bit more simplified. Sum over I yi, sum over I yi is equals to this thing going on the other side. A is a constant. Look, so how many data points we have taken? N number of data points are taken. I is equals to 1 to n. So a plus a plus a plus a plus a and so on. So how many times a is there? N times a. So this will be na, and this b sum over I xi will be there. So let's name this equation 1. On the other hand, for this, if you consider that sum over I xi yi equals to a times sum over I xi plus b times sum over I xi square equals to 0. Let's say this is equation. We got these two equations. Equation 1 and 2. Equations 1 and 2 are called normal equation. By solving these two equations, we get A and B. Which can be used to get the line of best. Understood? Yeah, submission is required at all the places, because this was just a constant, so that will be NA every time. But sum over I xi, this will depend upon the given data set. Whatever data set it will be given, you have to add the x parts, x1, x2, x3 and so on. Here you have to add all the y, y1, y2, y3. Here you have to multiply x1, y1, x2, y2, x3, y3 and then you have to add. Okay, because this was purely constant, n times A is NA. Got it, Murli? Any other question, guys, from this? If everything is all right, we can go to a problem. It seems there is no issue, so let's go for this problem. Try to do it with the given formula. So what you require x sum over xi, sum over yi, sum over xi yi and xi square. So these many things you require to apply this formula. So let's make a table for them. How many set of values are there? So there are 5 values. So we can start from here. one is for xi, another one is for yi, xi square and xi yi. Here we will be writing the sum. Total 5 values, 1, 5. We will do in this way. You will be writing the values of xi, yi, xi square, xi, yi. Okay. The value of xi's are 1, 2, 3, 4, 5. 4, 5. Value of y 3, 4, 5, 6. Who is messaging me so much? Wait a moment. Xi square 1, 4, 9, 16, 25. Xi yi 3, 8, 15, 24, 40. What is the value of sum over xi? Sum over xi is 15. Sum over xi is equals to 3, 6, 10, 15. Sum over yi, how much? 3, 4, 12, 10, 20, 26. Sum over xi square 30, 40, 50, 55. Sum over xi yi, how much? 40, 60, 70, 80, 90. Okay, so you got the values. So what equations we had? We had normal equations, sum over yi equals to n times a plus sum over I xi b into sum over I xi. Okay, next sum over I xi yi is equals to a times sum over I xi plus इक्वल टू 0 क्यों लिखा है हम लोगों ने, प्लस बी टाइम एक्स स्क्वायर. Okay, we need to solve these two equations. Sum over yi, we have already got it. What is sum over yi? It is 26. 26 is equals to n times a. How many total values? 1, 2, 3, 4, 5. N equals to 5. 5a plus x sum over xi. Sum over xi is 15. 15. This is equation number 3. Sum over xi is 90 equals to a into sum over xi 15a plus b into sum over xi square 55. So somehow we need to solve these two equations. You can just multiply equation 3 by 3. Okay, then you can just subtract equation 4. 78 15a plus 45 B. Okay. And 90, 15A, 55. Okay, just you take, you just do the negative. What you are getting? Twelve is equals to 10B. So B is equals to 12 by 10, 6 by 5, 0 point, sorry, 0 point, 1 point, 1.2, and if B is equals to 1.2, A, value of A will be evaluated. This will come out to be 1.6. 26 minus, you can also do it from here, A is equals to 26 minus 15 to be divided by, this is equals to 1.6. Therefore, the correctly fitted straight line is y is equals to 1.6 plus 1.2x. That is matching with option A. Is it clear, guys? Anyone has any question? Now let's talk about this thing, least square fitting method for fitting a non-linear relationship. So fitting non-linear relations that can be converted into linear form using least square method. So let's say you have some data points and we need to fit it curve like this, a b to the power x, this kind of curve, or y is equals to a x to the power b, or let's say you have y is equals to a e to the power b. So in this kind of non-linear curve, if you want to fit with your data point, then what you can do? So these non-linear equations, these nonlinear equations can be converted into the linear form y is equals to a plus bx by, how can we convert this nonlinear equation into a linear one? Anyone? What can you do so that this nonlinear equation gets converted into a linear one? By taking logarithms, right? Logarithms on both sides. So once you are given a nonlinear equation, we'll apply logarithm on both sides. Then we can apply the least square fit method. once the linear relationship is obtained. So, if you look at this thing, only one method, least square method of fitting linear, that is important, and other things will just follow. Once you get the linear relationship, you can apply the method of least square. Let me give you a problem to understand it better. Let's take this kind of thing. Given the following data, fit an equation in the form ax to the power p. So, what is unknown here? A is unknown, B is unknown. Once you get to know A and B, you get the equation. You have to find out the value of A and the value of B. So, what did I tell you? What you have to do? You have to first convert into a linear equation. This is a non-linear equation which you need to fit. So, y is equals to ax to the power b. If you take logarithm on both sides, logarithm means logarithm, natural logarithm, okay. This is equals to ln a plus b ln x. Now, this whole thing of ln a we are representing by, let us say, y, capital Y. Ln y is capital Y, ln a is capital A plus this b ln x, b ln x, ln x, b you are calling it as capital B, ln x is capital X, okay, where capital Y is equals to ln of small y, capital A is equals to ln of small a, capital B is equals to small b, and capital X equals to ln of small x. Understood? Again, we have got the linear relationship, so we can just make this table again. Once you get the form in a linear form, we can apply the method of least square. So, to apply the method of least square, we will start with the given points. Okay. So, what you require? You require this table. Let us make it big, like this. So, you have the value of xi, you have the value of yi, you need y, capital Y is equals to ln of small y, you need x, capital X, ln of small x, you need x square, capital of x square, and xy. Okay. So, what you need? You need xi, we need yi, we need capital Y, which is ln of small y, we need capital X, that is ln of small x, and we need x square, and we need sum over xi and yi and xy. Okay. How many total values are there? 5 values are there, and ultimately we need to do a sum. Total 5 values. So, this is for one value 3, 5. Okay. First value, second value, third, fourth, fifth. What are those values given to you? Look at it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The corresponding value of y, 0.5, 2, 4.5, 0.5, 2, 4.5, 8, and what 12.5. 12.5. So look, these questions will take some time. So it is highly expected that it will be given in the 5 mark section. And calculators are allowed, so you don't need to worry about it. Y is equals to ln of y. So ln of 0.5. So that is minus 0.6931. You can easily calculate with the calculator. Okay, calculators are allowed, so you can expect this kind of question. ln2 is plus 0.6931. ln of 4.5 is 1.5041. ln of 8 is 2.0794, and this ln of 12.5 you can calculate using a calculator, 2.5257. and if calculators are not allowed, then these values will be provided to you. X is equals to ln of x. ln of 1 is 0. ln of 2 0.6931. ln of 3 1.0986. this is ln of 4 ln of 4 is 1. Have we written anything wrong? 3863. and ln of 5 1.6094. Okay, now you need to calculate x square. X square means this column square. X 0 square is 0.693. 1 whole square is 0.4804. 1.0986 whole square is 1.2069. 1.3863. 1.9218. 1.6094. so 2.5902. xy. X is this, y is this, capital XY. Okay, so this first term is 0, second term 0.693 into this. So these two columns are multiplied. 0.6931 square, 0.4804. Here it will give you 1.6524, 2.8827, 4.0649. So what you require? Look, we require mainly this thing, xi square, xi yy. Now here just we have expressed it into capital symbols. So sum over y, sum over capital Y. Let's say capital YI. What will be this? If you add all of this, you will get it 6.1092. Okay. Oh, can we make it? Okay, we are writing it in this way, 6.1092. Sum over xi. This will goes to 4.7874. This will be equals to sum over xi square. This is equals to 6.1993. This is sum over xi yi. This is equals to 9.0804. You can take these calculations. Okay, so normal equations you can write now. What are the normal equation? Just follow the procedure. Normal equations you will be writing in the terms of the this quantity. So look, previously it was sum over yi, so here you will be writing capital Yi. This is equals to n times a was thus n times capital A plus b sum over I xi, and here sum over I xi yi is equals to a times sum over I xi plus b times sum over I xi square. So, if it will be very best if you can remember these two normal equations, otherwise you have to derive it, and that will take a lot of time. So, I will recommend you that you just remember. And if you carefully look at, you just need to remember the first one. The second one is like just xi has been multiplied now. This n has been removed. So, it is like xi has been multiplied. We can remember in that way. Although it is not exactly we get the second equation by multiplying xi, but it appears to be. Like 90% similarity is there if you just multiply with xi, but this n factor is going out. So, if we put all these values, you will get 6.1092 is equals to 5a plus 4.7874b, and then 9.0804 is equals to 4.7874 a plus 6.1993 b. Now, if you solve these two equations, solving the above equations with the help of a calculator, you can easily solve. Manually it is difficult, but with the help of a calculator you can do it. You will get a is equals to minus 0.6931, and you will get b is equals to 2.0. Okay, so the calculation is not over yet. A is equals to ln of a, right? So, what you got? The value of ln of a we have got. So, ln of a is equals to minus 0.6931. So, from this you will get the value of a to be 0.5. On the other hand, b is equals to 2, and you see b, capital B is equals to small b. Okay, the small b is equals to 2.0, and that is why therefore the desired curve, the best fitted curve is given by y is equals to ax to the power b was there, ax to the power b. So, a means 0.5 x to the power 0.5 x square, and that is matching with option C. Tell me guys if it is clear. Simple questions, but difficult, little bit clumsy calculations. In previous problems we multiply by 3 to cancel one term. Now what we do here to find a and b. So, we have to find, look, this can be done with the help of a calculator. If this is 5, okay, so you find out some factor. Let's say you can do 5 by 4.7874. So, you will, from that you will get the factor, right? 5 by 4.7874, if you calculate, the result will give you the factor. So, multiply with that factor this second equation, then here will be, it will be 5a, and here also it will be 5a. So, once you get 5a, and you can just then subtract, and then from that you can get the value of b. Once you get the value of b, you put the value of b here, and you will get the value of a. It is just that, because previously we multiplied with 3 because those are integers, whole integers. Here we have in decimal. So, with the help of a calculator you can do. Got the point, or should I discuss it again? Harry, tell me. Not understood? Got it? Okay. Chalo. Now, least square method for fitting a nonlinear relationship, nonlinear regression, fitting polynomial function using least square method. So, we have seen two cases previously, y equals to a plus bx, linear case, y equals to ax to the power b, a b to the power x. Other things can also be done. Okay, if you have let us say y is equals to a b to the power x, then taking logarithm on both sides will produce then what we can do, we can take this as capital Y, this as capital A, this as capital B, and SS, then B will become ln B, okay, X will be X, A is ln A, and Y is ln Y. Regression meaning, this process in statistical is called regression. Regression, the literal meaning is a return to a previous state. If you talk about the meaning of regression, a return to previous step. So you are assuming something and you are going back to the original result. So the literal meaning, if you want to get another literal meaning, to go back. Okay, this is a language used in a statistical method. Okay, आगे बढ़े दोस्तों. This one is for y equals to, अच्छा. Now if you have, we have already discussed this. Let's take y is equals to a to the power bx. If you are given like this, you will take ln y is equals to ln a plus what it will give you, b x ln e. Ln e is 1, so it is bx. So it is equals to y a b x. Okay, y is equals to ln y, a is equals to ln a, b is equals to small b, and x is equals to x ln e is equals to x. Okay, so there is no issue. Let's move on. Fitting polynomial function using least square method, nonlinear regression. Regression, you for the timing you can meaning nonlinear curve fitting. Let y is equals to a1 plus a2x plus a3 x square, let's say up to a m x to the power m minus 1, a3 x to the power 3 minus 1, a2 x to the power 2 minus 1. This is the curve. Be the curve of best fit for the data set let's say x1 y1 x2 y2 x3 y3. Let's say we have n number of data sets. Action y. Now with the help of normal equation, with the method of least square fitting, we can get the normal equation using the least square method. We can get the normal equations. Normal equations we can remember sum over I yi is equals to n times a1 sum over yi equals to n times a1 na1 plus a2 sum over I xi plus a3 sum over I xi square and so on plus am sum over I xi to the power m minus 1. Okay, and sum over I xi yi, you will get a1 times xi, a2 times xi square. Okay, a3 times xi cube. So am will become xi to the power m. So it is like xi has been multiplied. So how many equations you require here? How many equations you require here? How many unknowns we have? A1, A2, A3 up to AM. M number of unknowns we have. So how many equations you require at least? At least how many equations you do require? M number of equations you require. But here we have only 2. Okay. So you will keep on multiplying xi and we will keep on getting equations. You will keep on getting equations. So we require m number of equations. If I write the last equation, let's say xi to the power m minus 1 has been multiplied, we will get it like this. xi was there and we have multiplied with xi to the power m minus 1. So what it will become? This will become sum over xi to the power m. A3, how much will it will become? It will become it will become xi to the power m plus 1, right? And so on. The last term will be am sum over I xi to the power m minus 1 and m minus 1. So 2 into m minus 1. So 2m minus. Look, in your actual problem, there will not be this many values. There may be 3-4 values, and you can easily crack it. So solving these m equations, solving these m equations, we can get the values of the m unknown constant a1, a2, a3 up to m. And the curve of best fit can be generated. Is it understood, guys? Or if anyone has any question, you can ask. Let's take a problem. Are you ready? Give it a try. Fit a second order polynomial to the given data. Second order polynomial. So up to how many terms it will be there? How many terms? What will be the expression of y? If you want to fit a second order polynomial, what will be the second order polynomial here? Second order polynomial. So your y will be, you can take a1 plus a2x plus a3 x square. Do it quickly. I'm making options, okay? Y is equals to 1 plus x square. Option 2, 2 plus 3x plus 5x square. Y is equals to 3 plus 2x plus x square. Y is equals to let's say 1 minus 2x plus. Okay, give it a try. Hurry up, guys. We do not have all the day. One more problem left after this. We'll be done with this. I think you have understood, right? Least square fitting. Any function you are given, you can do it. We have done for the straight line, the simplest one. Then we have done for the nonlinear, which can be solved by taking logarithm on both sides. Then this third one, or last one, the general one, polynomial, fitting a polynomial. Murli, Vantage, Harry, Ajay, where is Ajay? Ajay remains so silent. Doing calculation, Ajay? Are you able to do it, guys? We have to fit a second order polynomial. So let's take, let y is equals to a1 plus a2x plus a3x square be the required polynomial. Be the required polynomial. So the normal equations are, what will be the normal equations? Sum over I yi is equals to n times a1 plus a2 sum over I xi plus a3 sum over I xi square. So the second one will be by multiplying xi, let's say xi yi, n will be missing, a1 sum over I xi, a2 sum over I xi square, a3 sum over I xi cube. Okay, next you have to take xi square yi, a1 xi square, a2 xi cube, a3 xi to the power 4. That's it. We are having three unknown quantities, a1, a2, a3. So we require only three equations. Now you just need to put the values in. Sum over xi is this. You using the given data. You can make a table, but I'm feeling lazy, so I'm not making table. Using the given data, you can just manually check sum over ixi. Add them 1, 2, 3, 4. Get on the dance floor. 1, 2, 3, 4, 7, 9, 10. Next, sum over yi. Just add them up. 6, 11, 18, 27. This will give you 62. sum over xi square. What is that? Sum over xi square 30. Sum over xi cube, this will give you 100. You can check it. Sum over xi to the power 4, 354 will get. Sum over xi yi will get 190. Sum over I xi square yi will get 640. So once you get these values, we can substituting these values into the normal equations. We get, what do you get? Just put the values in. 62 is equals to 4a1 plus 10a2 plus 30a3. Then 190, 10a1 plus 30a2 plus 100a3. Then 644, 30a1, 10a2, 354 a3. Now solving these equations becomes really very tough. So this kind of problem you may not get in your examination, because you have to solve it by some advanced mathematical technique is required to solve this kind of simultaneous equations. I think there is something called Cramer's rule. Cramer's rule or something. With the help of that, you can solve these equations. Okay, so this is just for your understanding. Solving these equations, we get the values. A1 is equals to 3, A2 is equals to 2, A3 is equals to 1. So look, let me tell you a shortcut for this. If you start solving these equations, then it will take several hours, and it may be possible that you even may not be able to solve it. So the best way to handle such situation is to look at the options. What are the options? Look, in the first option you have 1, 1, 1. So if you put 1, 1, 1, does the equation get satisfied? No. If you choose 2, 3, 5, just put 2, 3, 5 at the value of A1, A2, A3. Do they satisfy? They may not, they may satisfy, they may not satisfy. If you check, let's say 3, 2, 1, 3, 2, 1. Let's apply it on the first equation, 3, 2, 1. 3, 2, 1. 12, 20, 30. 30, 50, 60, 62. So it is satisfying. Okay. And if you take the last one, 1 minus 2 plus 5, 1 minus 2 plus 5, let's say if you take 1 minus 2 plus 5, it will not satisfy. So obviously this 3 to 1, this option is correct. So sometimes we need to apply our, because the tricky sense, that is not a common sense, this is a tricky sense. This will come after several times of practice. Okay. You understand? In your examination, you will be given MCQs. So you have to find the final answer. You have to find the final answer key by any cost. Whether you get the correct answer key by exactly solving the whole problem, or you can use some property, you can use dimensional method, you can use any trick, whatever you use, if that is correct, you will end up getting the correct answer. Okay. Here, instead of solving these big equations, we are just testing the value putting thing. We put the values, we saw that one of the options is correct. This is not multi-select questions. It's a single select question, so it's a great opportunity, guys. Multi-select questions are a little bit pain. In the third equation, 100A2. Wow. Murli has got a good eye. Thank you, Murli. One problem I'm giving as homework, okay? You will do it at home. The iron losses. The iron losses in a ferromagnetic material used in a transformer vary with frequency f of the supply given to the transformer. For a particular transformer, these iron losses were determined at various frequencies with a constant flux density in the ferromagnetic material. The results are. Don't get confused with these lines, you just focus on the table. In the table, what you can see? Frequency and iron losses in terms of iron losses P. This is the unit, milliwatt. Okay, 4 data point are assuming the iron losses to have the general form AF square plus BF. Okay, you can find normal equation based on this. Determine the constants A and B to achieve best fit for the 4 measured values using the method of least square. So we need to find out the value of A and B. Okay, we will try at home, and I will share the solution in the WhatsApp group, or you can also share your solution either in the WhatsApp group or you can also DM me. Okay. So with this, we end this lecture here. I hope you find this session useful, and this is particularly very important topic. Many students just leave this topic, but I have just gathered this material from various sources, okay, from many books we have collected and just summarized it at one place. So this particular lecture is very precious lecture. Anyways, thank you guys. Thank you very much for joining the session. Bye bye. Take care. Have a great day.